And hi, everyone. It's great to see you all here. Thanks for coming to this session today. As Sarah said, my name is Ian. I'm excited to be talking to you all about a couple of ongoing projects that we have at the Leventhal Map Center, the Boston Public Library. Specifically, I'm going to be talking about two things. Atlascope, which is our tool for examining digitized and georeferenced urban atlases of the greater Boston area, and Allmaps, which some of you may have heard of. It's a tool for georeferencing scanned maps completely online. So I'll dive into detail about both how we're using Allmaps to scale up Atlascope to other towns and cities outside the Boston area, and I'll meditate a little bit on what some of the wider implications for map-holding institutions I think these kinds of tools can have. So let's jump into it. The Leventhal Map Education Center, just by way of introduction, is an independent nonprofit that operates in the Boston Public Library. We are technically distinct from BPL as an entity, but for all intents and purposes, we are the Maps Department. We work with BPL and Special Collections to steward the collection of about 250,000 cartographic objects at BPL. That includes flat maps, rolled maps, globes, charts, atlases, the last of which I will be talking about in quite a lot of detail today. The top right photo there is BPL. The bottom left is our public gallery where we exhibit these maps and keep them on display for public enjoyment and learning. Right now we have two exhibitions up. One is about the city of Boston's history and the other one is about public transit. So if anyone is in or around Boston ever, feel free to hit me up and I would love to show you around the center and the library. On the right-hand side, we've got a little snapshot of our learning center, which is where we bring folks in for especially K-12 students and university courses to examine the maps in greater detail, and we also host geography books and atlases there. So here's the sort of organizing problem that I want to think about today. How can map-holding institutions maximize accessibility, discovery, and interpretation within and across their collections? I think the answers to this question can take a lot of different shapes, but I'm going to move through three today. One is to think about how we can take atlases and port them into sort of bespoke tools, such as Atlascope, to improve the way that patrons and other researchers can engage with them. The second is to think about how we can improve georeferencing workflows in general. And the last one is to think a little bit about how libraries can be leveraged as institutions for digital infrastructure rather than just places where we can go to download maps. So let's start with this first thing, from atlases to Atlascope. Most of the folks in this room, whether you're geographers or cartographers or librarians, are probably familiar with some variation of the thing that I've got on the screen right now. On the left-hand side, we've got a big stack of old urban atlases. Often, most people recognize these as Sanborn maps. Those are actually not the most common ones that we have at BPL and the Map Center. We mostly have Bromleys, which were tax atlases. Instead of demarcating in great detail building material and structure, though they do capture that, Bromleys are really good for property information. So folks who are interested in the changing geographies of land ownership, for example, get a lot of use and leeway out of Bromley maps. There's a little screenshot of one of the maps in detail, and you can see that all of these parcels of land and buildings are listed with an owner. So these materials are really important for people doing historical research, whether it is intensive archival work at a university level, or it's just casual genealogical research about family history. These maps can be super, super important for lots of different purposes. Here's a screenshot of our digital collections at the Map Center, where we have about 12,000 maps, really 12,000 objects, completely scanned and digitized and freely available. So that's great that we have that. If you sort of zoom in a little deeper, you can look at these atlases in a gallery form. Again, all of this stuff is probably pretty familiar, and dive into individual pages quite seamlessly. Now, even though it's great to have these available, that doesn't really mean that they're accessible. There are ways that we can improve the accessibility of these objects by not just serving them online, but actually transforming them so that they overlay with modern geographies as they would have in the real world. All right. So all that to say, georeferenced atlases are a really important source of information, but often they're hard to use, right? You don't really want to be flipping through those big books every time you want to compare 1910 and 1920. So the answer to this is georeferencing, of course. I think most folks here will be familiar with that process, but when I talk about georeferencing, I just mean the process of assigning control points to scan the pixel space of scanned images that correlate to latitudes and longitudes in the sort of real world, so to speak. Atlascope is our digital tool for accessing georeferenced urban atlases, like the ones that we were just looking at. I'm going to go ahead and do a little demo of this, which is always risky, but we're going to go for it. This is Atlascope, the front page of Atlascope. We released a new version this year. That sort of revamps the code base, so you can examine the many different coverage areas we have, both within and beyond Boston. Let's jump into one of the new ones. We can go over to Salem. So you can see here that we've got two. I think the Wi-Fi is I've noticed it's a little shaky here, so normally it loads a bit faster, but this is a great teaching moment for how XYZ tiles get rendered. Anyway, so we've got our little drawers down here for moving through controls. We can change it to different swiping views. This is all built in Svelte and open layers for anyone who's interested in the libraries underneath it, and you can check out the code base itself on GitHub. In Salem, we have added two atlases, 1911 and 1874. Again, we've got our little tiling process here, but it's a pretty seamless movement once this stuff has been cached and loaded of these historic maps. And you can see if you look, you don't even have to look that closely, right, that these are different layers that have been stitched together using a sort of classic georeferencing process. I also want to highlight a couple of the new features that we have added in the last year, which include map annotations. Let's go ahead and just make an annotation right now. So using this little annotation feature, we can grab space on the map and put information on it, right? So Ian showed the Salem Common to a wonderful audience at NACIS 2023. I'll save that annotation, and if we stop, it immediately gets cached in our fauna database, and we can load annotations and jump right to it. So this is one way, right, that we're trying to combine these historic materials with different kinds of public interest and give people the chance to not just see these maps and use them, but actually mark them up and tell stories with them. I think the most robust kind of storytelling that we've added in this tool are Atlascope tours. Atlascope tours are sort of, they are what they sound like. They are tours through different views and scenes in Atlascope. We had some really amazing interns this summer who put together a couple of amazing tours about Harvard University's land expansion in Boston and Cambridge, as well as the history of Massachusetts rubber industry, and sort of using the atlas layers in Atlascope to provide captions and other sort of research resources to look at spaces in Massachusetts where the sort of stamp of rubber can be found, right? And then linking that up to global trade circuits in the 19th and 20th centuries and thinking about the relationships between like Salem or Watertown and the Congo, right? We can tell those stories and actually learn new things about them through examining these maps closely. I think that's about it on Atlascope. So let's jump back in here. Yeah. So that's Atlascope, right? This is sort of the product. We are continuously adding new layers to this tool. For a couple of years, it was serving 101 atlases, and you can see now we're up to 112. We've been working with a lot of really amazing interns to add new layers. And I should also shout out Belle Lipton, who did a ton of the sort of original work to make this tool happen. So it's built through the labor of thousands of hours of Map Center staff members, interns, and lots of other folks who've been involved in this project. All right. So let's talk a little bit about georeferencing. Again, you all are probably familiar with doing this in QGIS or ArcGIS, what have you. I want to talk a little bit about the different methods that we use to georeference Atlascope traditionally and what we've been migrating towards over the last year. So QGIS, pretty classic. You can pop open the georeferencer, download the software, pull down a TIFF image, high quality, was going to run you like 150 megabytes, and plop this into the georeferencer. It's sort of a clunky interface. I've never loved it. You have to toggle back and forth between different windows. Oftentimes there are sort of project settings that you'll want to edit so that you can mask out the empty space of pixels, and that's all stuff you have to configure in Python if you want it to be seamless. So it can be kind of tricky. And the same goes for ArcPro. Although I should admit that I haven't actually used ArcPro to georeference ever. I haven't had an ArcGIS license since this sort of replaced desktop. So I'll withhold comments on Arc because I just don't know. Those are the two desktop versions. There are a few online georeferencing softwares as well. MapWarper was a really useful georeferencer that was popular for, a decade at least. We used it at the Map Center, but recently it has sort of stopped. It is continually maintained, but we run into all sorts of deprecated sort of dependency issues. If you want to talk about that more, grab me after the presentation. It's sort of a bear to update our collections portal with MapWarper inside it. That's the short story. So there are reasons that we wanted to unspin this, and it still relies on those flat image files in order to do transformations. While I was finishing these slides this morning, many folks may be familiar with Clocan, which had a georeferencing tool at georeferencer.com. This is about 12 years old. I think they started in 2011. A lot of really amazing work on this, but I didn't know this happened. It's no longer available. So at georeferencer.com, I had to go grab this from the Internet Archive. As of, I think, January 27th this year, this is what opens when you go to the Clocan page. I would love to know more if anyone knows sort of what happened. I did a little bit of digging. On January 27th, it started redirecting you to Old Maps Online, which is another resource for georeferenced maps. And again, this one relies on a big database of image files, and both the source TIFFs and the transformed geotiffs. So you can see how as you are, and here's a screenshot of Old Maps Online. This is a tool that you can't use for free, right? You have to get a quote for it if you want to use it institutionally. And you're allowed to have one map in it. So I hit my limit this morning when I tried to georeference a new map of Boston. I needed to upgrade my plan, which I didn't do. So all that to say, there's an urgent need for software that's free, open source, and easy to use if you want to georeference. And that's where Allmaps comes in. And I'll sort of spend the remainder of my time talking a little bit about this and some of the protocols that underpin what I think is a really exciting software. So Allmaps leverages something called the International Image Interoperability Framework, IIIF, much easier to say, to warp scanned maps entirely in a web browser. This is sort of transformative for the way that we think about georeferencing happening, in my opinion. Right? So instead of loading a geotiff into some kind of system, whether it is a desktop software or a web browser, right? Allmaps is completely operating based on a URL. I should note that Clocan's georeferencer also can do this, but it has the critical, the missing ingredient is that it's not free to use for either me or an institution. So Allmaps is the other softwares associated with this are things like WebGL. You can, again, check out the code base for Allmaps, which is completely public on GitHub if you want to learn more about how it's built. But I want to go quickly through the key features that we use at the Map Center, which include the Allmaps editor, and that's the sort of georeferencing interface itself. The Allmaps viewer, which is where you can view georeferenced maps at the level of the object, so a full urban atlas, for example. The Allmaps command line interface, which we use in our sort of post-processing work for urban atlases before they go into Atlascope. And the tile server, which every map that gets georeferenced in Allmaps immediately spins up an XYZ tile endpoint that you can easily load into QGIS or ArcGIS Pro on a desktop, making it sort of backwards compatible in this way that you can still use it with desktop software. So over the past year, we have sort of placed Allmaps at the center of our georeferencing workflow for the new urban atlases that have gone into Allmaps. That has been a really exciting process. We're sort of stress testing Allmaps, which is by no means a finished product, so we're finding all sorts of little bugs and issues, and in many ways this sort of helped us think through what this kind of software can offer for other institutions. This is the table that we use to manage our georeferencing progress. And I'll just go ahead and, by way of example, highlight this atlas of the city of Lynn, which went into Atlascope over the summer. So let's take a look at this. I am very excited to share that we just got some new buttons on our digital collections portal. You can now view the IIIF manifest straight from here. It took us a long time to get this stuff sorted out, partially because we can't edit the portal because of the map warper stuff. This is the IIIF manifest of this object. IIIF, to sort of give you an overview of this protocol, is just a way of attaching metadata to an image that includes information about its dimensions and its sourcing, and associates it with a particular institution. It makes it much easier to share images between institutions and sort of derivative web apps using just a JSON file. This is just JavaScript object notation. Allmaps uses that URL, and now if you want to georeference stuff, you can both view a map, view a georeferenced map in Allmaps, improve the georeferencing, or access the georeference annotation. This is the Allmaps georeference annotation that makes everything work in the Allmaps ecosystem. Every time a map is edited in Allmaps, this JSON file gets spun up and associates the pixel space coordinates with the real geography coordinates. So instead of creating a geotiff that you need to store somewhere and serve out, right, this is the file that will ultimately be warped on the client side of a user's web browser. Let's take a look at how the app actually works. So this is Allmaps Viewer. It's probably going to take a minute to load, but let's see. Yeah, so we've got some masks coming in. Again, I think that this Wi-Fi is a little shaky, but we'll let that think. And then I'll pull up Allmaps Editor as well, which immediately begins to process and display all of the canvases. That's the sort of technical term for the images associated with each object in the manifest. All right, so Allmaps has 3 tiers. You can do, you've got your manifest, your image, and then multiple maps inside each image. Instead of georeferencing these, I will let you all kind of explore that on your own time and start to wrap up here. What I want to emphasize, and I'll close on this slide, is that instead of creating all these derivative and duplicative materials through georeferencing, Allmaps has allowed us to leverage existing infrastructure that libraries already provide, right? So instead of remaking the wheel, as it were, we can just use the images that are being served publicly from libraries and map holding institutions and make use of them for access and discovery and research. I think that's all. I can explain that later if you want. We got a grant to support this, so I want to talk more about that, but I will later. Thank you.